Welcome to this virtual session. We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximise, minimise and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Hi, my name is Neil McIsaac, and I'm a Microsoft Technical Trainer within Worldwide Learning here at Microsoft. And I'm responsible for providing technical skilling on Microsoft's cloud technologies to our top enterprise customers. I've been in the IT industry for over 30 years now, and I've been supporting Azure since 2008, which is about 2 years before Azure was generally available to the public. And with that, I'd like to welcome everyone to this Microsoft Azure Virtual Training Day, implementing a data lakehouse with Microsoft Fabric event. In part 1 of this event, we'll cover the first 3 sessions of the course. We'll begin with an introduction to end-to-end analysis using Microsoft Fabric. In session 2, we cover getting started with Lakehouses in Microsoft Fabric. Then we'll wrap up part 1 explaining how to use Apache Spark in Microsoft Fabric. In part 2, we cover the final 3 sessions of the course. We start with session 4 on working with Delta Lake tables in Microsoft Fabric. Session 5, we'll cover ingesting data with Data Flows Gen 2 in Microsoft Fabric. And then finally, we wrap up part 2 and the event with using Data Factory pipelines in Microsoft Fabric. With that, let's get started with session 1. In this session, we'll be doing an introduction to end-to-end analytics using Microsoft Fabric. Specifically, we'll start by describing how Microsoft Fabric enables end-to-end analytics. We'll then discuss how different data teams can use Microsoft Fabric for their different needs. And then we'll cover how you can enable Microsoft Fabric for your organization. Let's get started with an introduction to Microsoft Fabric and how it can be used to deliver end-to-end analytics. As you probably already know, data analytics is complex. Historically, it involves many teams working with many products and using many copies of data to accomplish the various tasks that they need to complete. These tasks can range from things like data stewardship tasks, such as cleaning and preparing data, or delivering data to various reporting solutions, or performing data science tasks like training AI models. Since these teams often use many different tools, coordinating and connecting these tools has generally been a hassle, with trying to configure how the tools work together and maintain some type of security between them all. Of course, typically this means that we end up having multiple copies of our data in multiple products. Combine that with the complexity of configuration and the security risks that go with that, and we have a lot to be worried about. Well, that's where Microsoft Fabric comes in. Microsoft Fabric combines multiple tools together so that you can accomplish all of these data analytics tasks through using a single product rather than multiple products. Microsoft Fabric combines the data integrity capabilities of Data Factory, the data engineering capabilities of Spark from Synapse, the data warehouse capabilities of SQL Pools from Synapse, the data science capabilities from Azure Machine Learning and Spark from Synapse, the real-time capabilities of Synapse, the reporting and business intelligence capabilities of Power BI, and the ability to trigger notifications and actions based on your data. If we need to have all of these tools work together within one product, we'll also need to have a common data platform. So Microsoft Fabric uses OneLake to host its data. OneLake is Fabric's lake-centric architecture that provides a single integrated environment to collaborate on data projects. You can think of it like OneDrive for data. OneLake combines storage locations across different regions and clouds into a single logical lake without moving or duplicating data. Data can be stored in any file format within OneLake and can be structured or unstructured. When it comes to tabular data, The analytical engines in Fabric use a Delta format when it writes the data to OneLake. All of the engines from all of the different tools can work with this format and treat Delta files as tables, no matter which engine wrote it. What this means is that for every Fabric tenant, you will always have exactly one OneLake. Never two, never zero. And there is no infrastructure to set up or manage. The concept of a tenant is a unique benefit of a SaaS service. It allows us to automatically provide a single management and governance boundary for an entire organization, which is ultimately under the control of a tenant admin. The admin sets this initial boundary, and any data which lands in OneLake will automatically take part in out-of-the-box data governance, such as data lineage, data protection, certification, catalog integration, etc. But all data is ultimately under the control of the tenant admin. However, it's important that different business groups are able to work independently without going through a central gatekeeper. Similar to having an office user not needing to coordinate with their office admin to create new Teams channels or SharePoint sites. OneLake enables distributed ownership through workspaces. Different workspaces allow different parts of the organization to work independently while still contributing to the same data lake. Each workspace can have its own administrator, access control, region, and capacity for billing. Creating a workspace is very lightweight. It inherits the rules set by the tenant admin, so there is no need to re-implement the same governance or spend time trying to get different resources to talk to each other. Workspace admins can further control access to the data within their workspace as needed. Let's take a closer look at some of the concepts that make up OneLake. Starting with OneLake, as we mentioned before, this is meant to be one place for an organization to store its data without the need to manage different storage resources. OneLake takes this even further with the introduction of domains. A single business domain may have multiple workspaces, as workspaces tend to align with specific projects or teams to help keep things organized. One copy. The purpose of one copy is to get the most value possible out of a single copy of data without data movement or duplication, which inherently lowers the risk to your data. Speaking about security, one security brings a shared universal security model, which you can define in OneLake. These security definitions live with the data rather than living downstream in the serving or presentation layers. And lastly, OneLake Data Hub. This is a central location within Fabric to discover, manage, and reuse data. If we actually look at how this data is stored in OneLake, you're not going to see data items in workspaces. You'll see files and folders just like you would in a proper data lake today. All workspaces are going to be folders, and each data item will be in a folder. Any tabular data will be stored in Delta Lake format. So we're not creating any new proprietary file formats for Fabric because proprietary formats do tend to create data silos. Even our data warehouse will natively store its data in Delta Lake Parquet format. While Fabric data items will standardize on Delta Parquet for tabular data, OneLake is still a data lake built on top of ADLS Gen 2. It will support any file type, structured or unstructured. How the data is stored is important because OneLake is not just a Fabric data lake or a Microsoft data lake. Based on the files, it can provide unique experiences to the different personas that use OneLake. And by bringing the data together, Microsoft Fabric makes it easier for data professionals to work together on data projects by essentially removing data silos and the need to access multiple systems, and ultimately enhancing collaboration between data professionals and teams. The very first step in all of this, of course, is to enable Microsoft Fabric for your organization. Fabric can be enabled at the tenant level or capacity level, meaning that it can be enabled for the entire organization or for a specific group of users. Also, the Fabric Administrator is a new role as of June 2023. This was formerly the Power BI Administrator role. If you'd like to check to see if you have access to Fabric in your organization's tenant, sign in to Power BI and look for the Power BI icon in the bottom of your left navigation pane. If you see the Power BI icon, click on it to see if you have the experiences available within Fabric. If the icon isn't present, Fabric is not available to you. For more information on the topics we've discussed in this session, you can check out the online material on Microsoft Learn, which you can find with the URL https://aka.ms/fabric-intro. In this session, we covered how Microsoft Fabric enables end-to-end analytics. We discussed how different data teams can use Microsoft Fabric for the data needs, including how OneLake helps to enable that. And then lastly, we covered how you can enable Microsoft Fabric for your organization. We'll now take a 10-minute break. See everyone back here when we get started with session 2, getting started with Lakehouses. Welcome back from the break. In this session, we'll be focusing on getting started with Lakehouses in Microsoft Fabric. Let's get started with session 2. In this session, we'll start with what a Lakehouse is. Then we'll discuss how to work with a Fabric Lakehouse, including how to explore, transform, and visualize your data in the Lakehouse. Let's get going with our first topic on this session on getting started with Lakehouses in Microsoft Fabric. The foundation of Microsoft Fabric is a Lakehouse, which is built on top of the OneLake scalable storage layer that we introduced in our first session. And it uses Apache Spark and SQL compute engines for big data processing. A Lakehouse is a unified platform that combines the flexible and scalable storage of a data lake and the ability to query and analyze data as a data warehouse. A Lakehouse presents as a database and is built on top of a data lake using Delta format tables. Lakehouses combine the SQL-based analytical capabilities of a relational data warehouse and the flexibility and scalability of a data lake. Lakehouses store all data formats, both structured and unstructured, and can be used with various analytics tools and programming languages. Lakehouses can also scale automatically and provide high availability and disaster recovery. Some other benefits of Lakehouses. They can utilize Spark and SQL engines for large-scale data processing and analytics, including machine learning and predictive modeling. They support a schema-on-read format, allowing flexible schema definitions as needed, rather than relying on a predefined schema. They can support ACID transactions through Delta Lake formatted tables, ensuring data consistency and integrity, and they provide a centralized location for data engineers, data scientists, and data analysts to access and utilize data and share. Loading data into your Lakehouse can be done a few different ways. You can manually upload your data from your computer. Use the copy tool in a pipeline, which is highly scalable and supports many different data sources and can be orchestrated many different ways. Use Dataflows Gen 2, which are based on data flows from Power BI and supports over 200 data connectors. So if you're already familiar with Power BI data flows, this is going to feel very familiar. And you can also import your data using notebooks and Apache Spark code, which allows for the maximum amount of flexibility in managing the import process for your data. Another great feature within Lakehouse is the ability to use a shortcut. A shortcut is a symbolic link which points from one data location to another. Just like you can create shortcuts for files in Windows or Linux, the data will appear in the shortcut location as if it were physically there. Traditionally, if you have tables in a data warehouse which you want to make available alongside other tables or files in Lakehouse, you would need to copy that data out of the warehouse and import the copy of the data into the Lakehouse. With OneLake, you simply create a shortcut in the Lakehouse pointing to the warehouse. The data will appear in your Lakehouse just as if you had physically copied it. Since you didn't copy it, when the data is updated in the warehouse, changes are automatically reflected into the Lakehouse. You can also use shortcuts to consolidate data across workspace and domains without changing the ownership of the data. In this example, Workspace B still owns the data. They still have ultimate control over who can access it and how it stays up to date. Many of you already have existing data lakes stored in ADLS Gen 2 or perhaps in Amazon S3 buckets. These lakes can continue to exist and be managed externally to Fabric. Also, shortcuts can support data that lives outside of OneLake and even outside of Azure so that you can virtualize your existing ADLS Gen 2 accounts or Amazon S3 buckets into OneLake. You can create a Lakehouse in the data engineering experience in any premium tier workspace. You can see which experience we're using if you look closely at the bottom left-hand corner of this screenshot. After creating a Lakehouse, you can load data in any common format from various sources, including local files, databases, or APIs. Once we create the Lakehouse, you get 3 named items. The Lakehouse, which represents how you work with files, folders, and your table data. The SQL endpoint, which is a read-only SQL endpoint which allows us to connect and query data using Transact SQL, and you get a data set, which is an automatically created data model based on the tables in your Lakehouse and is used by Power BI to build reports from. After loading data into Lakehouse, you can use various tools and techniques to explore and transform it, such as Apache Spark, which can use Spark pools through notebooks or Spark job definitions to process data in files and tables in the Lakehouse using languages like Scala, PySpark, or Spark SQL. Now, notebooks allow for an interactive coding interface in which you can use code to read, transform, and write data directly using the Lakehouse and can use both tables and files. On the other hand, Spark job definitions allow for on-demand or scheduled scripts that use the Spark engine to process data in the Lakehouse, which can be really useful for those routine data processing tasks that we all need to do. Each Lakehouse includes a SQL endpoint through which you can run transact SQL statements to query, filter, aggregate, and explore data in the Lakehouse tables using something that a lot of data professionals are familiar with, the SQL language. In addition to using a Dataflows Gen 2 to ingest data into the Lakehouse, you can also create a data flow to perform transformations through Power Query and optionally land the transformed data back into the Lakehouse. And you can also use data pipelines, which allow you to orchestrate complex data transformation logic that operates on data in the Lakehouse through a sequence of activities, including activities such as executing data flows, Spark jobs that we talked about, and other control flow logic. Of course, you can visualize your data using Power BI, which would allow users a more interactive interface, or you can also use the Spark engine to create charts and plots as well. Let's do a demo on creating Microsoft Fabric Lakehouse. All right, so let's start things off with going to Fabric, which you're going to do with HTTPS app.fabric.microsoft.com. And when we land on here, we do need a like a work account that has access. So we have an account there, that demo account that we can already has access to, like Power BI or something. And one of the first things you want to kind of look for is to see if Microsoft Fabric is enabled in your tenant. Now, down in the bottom left-hand corner, we can see Microsoft Fabric is listed here. So it is in fact enabled. So I'm going to start with changing the experience, which I'm going to switch to data engineering. And from there, we're going to make a brand new workspace instead of using my workspace, which is usually a good practice just in general. So from there, we're going to make a brand new workspace, and we'll call this DP601 demos. And let's get that. Oh, one thing about this, we do want to make sure that this is enabled for Fabric as well. So I'm just going to come down to the advanced section, and you'll see the licensing mode for this workspace. We want to make sure that we do have a Fabric license. In this case, I'm just going to use a trial, which you can do in on your own environment as well. And so let's go down here and apply. Now, once we're in here, we are able to make a lot of different items within our workspace. So you notice on the new button, there's a lot of different things that we can do, everything from reports, etc. But in this demo, we're going to create a brand new Lakehouse. So let's get that going, and we'll call this something like Lakehouse, something simple. Hopefully you have a better name in your own environment. Let's create. So this is probably very, project driven or something like that. Now, once this is created, we're using the Lakehouse view of this. We're going to upload a file. And before we do that, let's add a brand new subfolder. We want to keep things organized, and we'll call this data. And then in this data folder, we'll upload a file to it. So this is just going to be manually from our local environment here. So upload files, browse. Let's grab the sales CSV here. Sales CSV, and get this uploading. Now, if it's a bigger file, if this takes a little while, you can actually just leave it go. You can close this pane. And you might be wondering where the files are here. And this is a kind of a common thing. A lot of people come down and expand this and go, hey, where are my files? And maybe come down and try and refresh. And like, where is it? You actually need to click on the folder it wants to let me click here, click on the folder, and you'll see the files listed in the folder on the right-hand side. So we now have a file that is up and running in here. We can also do shortcuts, which we'll talk a little bit later we kind of mentioned in the session here. So in this Lakehouse, we want to add something new. We can do a new shortcut. Now this is where we can go and access something that is external. Currently we have ADLS Gen 2 and Amazon S3 for external sources, but we can do this with a link. And what's different here is that the data is going to remain in ADLS Gen 2 or like Amazon S3 in those buckets. They're not going to be copied in here, but they will appear like they exist in this Lakehouse as well. So it is possible to do that. Now, the next part is we want to take this file. It is currently just a CSV file sitting in storage, and like we mentioned in the session, we can upload all kinds of different types of files, formatted, unformatted, you name it. So this is a CSV. What we're going to do next is have this get loaded into a table. So with the ellipsis on the right-hand side, there's a load to tables function. You notice the icon is a table with a little delta symbol beside it, right? It might be a little hard to see there. But we're going to create a brand new table from this. And it's just really as easy as this, right? Little wizard, new table name, right? Use header for column name. So anything that we want to do for like the separators, any of this stuff, we can manage. Since it's a CSV, it's actually pretty easy, and we'll load this. Now, when that happens, under tables, right? It'll take a minute to load there. There we go. So now that it's loaded, we can see that there's a delta table under tables. We can expand, we can examine this. You can see that the schema has all been inferred, and we can see the preview of the data and everything in here. So if we look at this, we can actually look at the files that are supporting this. Remember that these are going to be translated into Delta table format, which is really a Parquet file with the Delta log information in here as well. So we can see that it is actually just being based on a file system, files in the file system in this case. So, all right, next up, we can also look at using SQL to work with this table. In order to do that, we're going to switch the endpoint. So switch over to the SQL endpoint. So right now, we happen to be looking at the data through the Explorer in here. But what we're going to do is we're going to back up to the Lakehouse, to the workspace. And instead of using the Lakehouse, right, which was the view that we were just looking at, we're going to switch to the SQL endpoint, which is right here. Now, when we do that, it's going to give us a much more SQL-focused view of all the data, right? So we can see that it still gives us the view. But notice now it gives us things like views and function store procedures and all that. And we can do a brand new query if we want to. So we can come in here, we can do kind of standard Transact SQL queries like, select something like item. And notice it's very aware of what the data is. And we'll do like, I don't know, quantity, right? From sales. And we can be a lot fancier with this, but you'll notice that we can actually run it. We see the data, that all the data coming back as results. We can visualize those results as well. So it's quite effective, right? Yep. We do have to select the statement on that, but so we can see that. All right, so the next part is kind of interesting. We can make a visual query. So up at the top here, this is something that I think is relatively unique in this interface. New visual query, where we start dragging and dropping the pieces of the query that we really want to work with. Now, this is going to basically create a power query behind it. And so when we do something like grab our table, All right, so let's go over, grab the sales table, drag it over here. All right, we can see that it's a very visual sort of interface. And from this, we can manipulate this. So under manage columns, right, we can choose what columns we want to see. Let's get rid of all of those. And let's do something like, let's do maybe the sales order number and the line number, something like that. And click on OK, and you'll see that the results are filtered. It also shows us what's going on. So not only is it selecting the table, but then it's doing this choose columns with respect to the steps that it's doing. Now, from all of that, we can play more. We can go through and group by a lot of this data in here, right? We can combine data. We can do some transformation. So this is actually, pretty effective to do some lightweight analysis, some transformations, etc., on your data. After we do all this, we might want to do some reporting. And so way down the bottom, you'll see the model tab. So a number of tabs in data and the query, which we're just looking at in the model tab. We can come into the model, and from this, generate a new report. So this will jump us out to a slightly different interface. And for those that are familiar with Power BI, this is really kind of the Power BI interface. So on the right-hand side, we can take that sales data, and let's grab, how about item and quantity? So something I did earlier, right? And you notice that it shows up in the interface just as a table, but we can take this visualization and we can change the visualization to really look like something else. So let's maybe turn around and turn this into, how about the clustered bar chart? Let's expand this so it's a little easier to see. And we can play with this. So we can do filtering. You notice on the right-hand side here, we can do filtering if we want certain items. It really is basically Power BI that's at play here. So all of this, from working with the Lakehouse, we can drive the queries, we can manipulate the files over to Delta tables, and then do all the reporting in here as well. So with that, that's a basic introduction to Lakehouse. Let's get back to our deck. For more information on the topics we've discussed in this session, you can check out the online material at Microsoft Learn, which you can find with the URL https://fabric-lakehouse. In this session, we covered getting started with Lakehouse as a Microsoft Fabric, where we examined how to work with the Lakehouse, including exploring, transforming, and visualizing your data in the Lakehouse. We'll now take a 10-minute break. See everyone back here then, when we will start session 3 using Apache Spark and Microsoft Fabric. Welcome back from the break. In this session, we'll be covering using Apache Spark in Microsoft Fabric. Let's get started with session 3. Specifically in this lesson, we'll be examining how to prepare for and run Spark within Fabric. We'll cover how to load and transform data by using Spark, including how to partition an output file. We'll then cover how to work with Spark SQL, and then lastly, we'll conclude with how to visualize data using Spark. Let's get going with our first topic on our session on using Apache Spark in Microsoft Fabric. Apache Spark is often used in conjunction with the data lake architecture to process and analyze large volumes of data stored in the data lake. You can use Spark in Fabric to do things like transform data or to maybe build a machine learning model. Apache Spark itself is a distributed data processing framework that enables large-scale data analytics by coordinating work across multiple processing nodes in a cluster. Put it more simply, Spark uses a divide and conquer approach to process large volumes of data quickly by distributing the work across multiple computers. The process of distributing tasks and collating the results are all handled automatically for you by Spark. In Fabric, each workspace is assigned a Spark cluster. An administrator can manage settings for the Spark cluster in the data engineering/science section of the workspace settings. The Spark open source ecosystem includes a wide selection of code libraries for common and sometimes very specialized tasks. You can configure your Spark compute to load in additional libraries that you might need. To edit and run Spark code in Microsoft Fabric, you can use notebooks or you can define a Spark job. Notebooks are used when you want to work with Spark interactively. Notebooks enable you to combine text, images, and code written in multiple languages to create an interactive artifact that you can share with others and collaborate on. Notebooks consist of one or more cells, each of which can contain markdown formatted content or executable code. You can run the code in each cell interactively in the notebook and see the results immediately. Spark jobs are a bit different. Spark jobs are used if you want to use Spark to ingest and transform data as part of an automated process. You can define a Spark job to run a script on demand or based on a schedule. To configure a Spark job, you need to create a Spark job definition within your workspace and specify the script it should run. You can also specify a reference file, for example, a Python file containing definitions of functions that are used in your script. And you can also specify a reference to a specific lakehouse containing all the data that the script wants to process. Natively, Spark uses a data structure called a resilient distributed data set, or RDD. But while you could write code that works directly with RDDs, the most commonly used data structure for working with structured data in Spark is the data frame, which is provided as part of the Spark SQL library. Data frames in Spark are similar to those in the ubiquitous Pandas Python library, but optimized to work in Spark's distributed processing environment. When loading data into data frames, you can either infer the schema of the data or you can specify it explicitly. When you infer the schema, Spark will examine the data that it reads and describe the schema. Usually Spark will do a pretty good job of inferring the schema, but if our data doesn't have some of the information, such as maybe column headers, it might need a little help. The other option is to explicitly describe the schema that is being loaded. This can give you complete control over the schema of the data frame. This would help in situations where Spark has trouble inferring the schema, such as a file that lacks header information for the columns. Data frame methods are functions or operations that allow you to manipulate and analyze data stored in tabular form. You can use the methods of the data frame class to filter, sort, group, and otherwise manipulate the data it contains. For example, the code in the cell here uses the select method to retrieve only the product ID and the line item total columns from the DF data frame. You can also chain methods together to perform a series of manipulations that result in a transformed data frame. For example, this example code chains the select and the where methods to create a new data frame containing the product ID and line item total columns for products with an order quantity of 1 or 2. To group and aggregate data, you can use the group by method and aggregate functions. For example, the PySpark code here counts the number of products for each quantity of orders. You can also use Spark to save the results of your transformations for further analysis or downstream processing. This code example saves the data frame into a Parquet file in the data lake, replacing any existing file of the same name. Partitioning is an optimization technique that enables Spark to maximize performance across the worker nodes by distributing the data across more than one file. Performance gains could be achieved by filtering data in queries, since this could help eliminate any unnecessary disk I/O. To save a data frame as a partitioned set of files, use the partition by method when writing the data. The following example saves the data frame and partitions the data by year. When reading partition data into a data frame, you can load data from any folder within the hierarchy by specifying explicit values, or you can use wildcards for the partition fields to load in more than one folder. The data frame API is part of a Spark library named Spark SQL, which enables data analysts to use SQL expressions to query and manipulate data. The Spark catalog is a metastore for storing relational data objects, such as views and tables. By using the Spark catalog, the Spark runtime can seamlessly integrate code written in any Spark-supported language with SQL expressions that may be more natural to some of the data analysts or developers. One of the simplest ways to make data in a data frame available for querying in the Spark catalog is to create a temporary view. A view is temporary, meaning that it's automatically deleted at the end of the current session. You can also create tables that are persisted in the catalog to define a database that can be queried using Spark SQL. Tables are metadata structures that store their underlying data in the storage location associated with the catalog. In Microsoft Fabric, data for managed tables is stored in the table storage location shown in your data lake, and any tables created using Spark are listed there. You can create an empty table by using the spark.catalog.createTable method, or you can save a data frame as a table by using its SaveAsTable method. Deleting a managed table also deletes its underlying data. You can also use the metastore to define tables to create a new table based on Delta files in an existing folder, or use external tables to save the data frame as a new set of Delta files in a location other than the default table store. If you delete those external tables from the metastore, the underlying Delta files in storage will be persisted. You can use the Spark SQL API in code written in any Spark-supported language to query data in the catalog. This PySpark code uses a SQL query to return data from the products table as a data frame. Within a notebook cell, you can also use the %% magic command to run SQL code very directly that queries objects within the catalog. One of the most intuitive ways to analyze the results of data queries is to visualize them as charts. Notebooks and Microsoft Fabric provide some basic charting capabilities in the user interface. And when that functionality doesn't provide what you need, you can use one of the many Python graphics libraries to create and display data visualizations within the notebook. When you display a data frame or run a SQL query in a Spark notebook, the results are displayed under the code cell. By default, results are rendered as a table, but you can change the results view to a chart and use the chart properties to customize how the chart visualizes the data. You can also take advantage of the many graphics packages that are available to Spark to create data visualizations in code. For example, Python supports a large selection of graphics packages, most of them built upon the base matplotlib library. The output from a graphics library can be rendered in a notebook, making it easy to combine code to ingest and manipulate data with inline data visualizations and markdown cells to provide commentary. Now, let's go through a demo on analyzing data with Spark. All right, so let's get started with the demo by uploading some files to our data engineering view here. So we're going to come over to Files, and we're going to upload some files, but this time we're going to upload a folder. And I have a folder here already called Orders. And inside of this, if we open it up, can't quite see it because it's we're looking for folders. But inside of this, there's actually 3 files in here, 3 CSVs. So we're going to take the entire folder and upload it. All right, upload 3 files to the site. Yes, that's correct. And we'll do the upload. And you see all 3 loading in there. And then let's close it. We also get, when we do it this way, we also get a folder in here similar to what we saw in the other demo from our previous session. Inside of this, of course, like I mentioned, we have the 3 files, right? So that's great. We're going to use these files for playing with Spark here coming up. So the next thing we want to do is to open up a brand new notebook. And this is right at the top of the menu, right? So we can open up an existing notebook or a brand new one. We're going to do a brand new one in this case. And it's going to go to our notebook interface, right, for this. As soon as the left-hand pane loads, you see that we can see our Lakehouse on the left-hand side. So we can edit this. This first one's actually Markdown. We can switch, convert to a Markdown cell if we want to, so we'd see it as Markdown. But in this case, we can just come in here and edit it. So we don't really need this one for what we're doing in this demo. All right, so actually I'll switch this one just so you can see it. Now below this, we're going to add new cells. I mentioned before that notebooks run on this concept of cells. And so we add this the cell, we can put all kinds of different Markdown or code, right? Currently it's set to work with PySpark and Python and it all this. But there's actually a really neat feature in this notebook interface. And I really like this because this is kind of a tedious chore that we often have to do with notebooks. So I'm going to delete this cell. And instead of going through and manually creating this, what I'm going to do is come over to this the orders folder and just expand this and grab the 2019 CSV, come over to the ellipsis, and right in here we can load the data in as Spark or Pandas. So I'm going to choose Spark here. And what it does is it loads in a cell with the read and all the settings in here for me. So let me just collapse this again just so we can see this a little bit better. And there's the cell. Now we can run this cell and see if this works okay, right? So it's reading it as a CSV file, saying, hey, yes, there's a header on it and the path to where that file is. And we'll see that this actually works, right? Hopefully it works. It should work. So it just needs to take a minute to go. And we will see our data. Now, the very first time you do this as well, notice it's starting a session. If you've used notebooks in the past, it can actually take a little bit of time for a session to initially start. Now, these are one of the things in Fabric is the time to get the session to start is actually quite quick. So it's pretty good. So there we have our table of results. So that's actually pretty neat to help you with a little bit of work. Now, of course, we can edit this. So if I come in and say, hey, the headers, you notice the data in here, like index, you see the dates not quite correct, but we can modify this and say, hey, there's no header information on this file, and let's rerun that. Of course, our session started now, so this should go nice and fast, and we'll see that the column names have all changed in this case, right? Because we're saying, hey, there's don't treat that first row as the header information. Okay, now from that, it's still not quite correct. This is still kind of ugly because the column names hopefully are not C0, C1. So let's come down below this. And below this cell, we're going to add another chunk of code here. And we're going to define the schema. Now, just for the sake of saving typing, I have a lot of these code blocks already done. So I'll show you this in just a second. Let me just come over here and steal that. And this next piece is really to define an order schema. And then we're going to read the same file, but we're going to say, hey, use that scheme instead. And all we're really doing here is we're defining what all the columns are as well as their types, so names and types for all that. So let's see if that runs okay. And hopefully we see the same data, but now we have all the column names fixed up for that. So far, so good. Now, we can continue playing on with this. One of the things that we might want to do is load in the entire folder. So let's come back up here. We'll kind of sort of cheat a little bit. We'll just edit this. Say we have the schema, but instead of loading in just files, orders, and just this one CSV, why don't we switch this around to load in all the CSVs in that directory? So I'm just making a small little edit here, and let's come back up and run that same cell. And in this case, we'll actually load in all the data. Now, this will actually only show the first 1,000 results or whatnot, but it did run okay using the asterisk. And so we see the order dates instead of 2019. It's actually showing 2021 in here. So you can play with this a little bit to see the different data being loaded. Okay, some of the other things we can do, we can filter these data frames. So let's come down, make a brand new cell. Let's grab a little more code. This little chunk right here. And let's see what this does. So basically, we're going to take that data frame that we defined earlier. So, sessions, variables, and objects that we defined earlier in the notebook that we've already executed are defined. So the data frame that we're using, we say, hey, I want the customers to only have these two fields, right? Customer name and email. Let's do a couple things, like let's do a count. Let's look at the distinct customers and count them, and then display all those customers as well. So let's run this cell. And what we should see, we see the counts, right? So we see the customers count and then the distinct count, so two different numbers. And then we see the display method is showing us the actual data for the distinct customers. All right, so from this, let's modify this a little bit. So let's add in, all right, let's come in here. Let's do a where the data frame item is equal to, and we're going to look for road. Hopefully I don't typo this. 250-250 space red. So this is just one of the items in here, and it's a 52. So it's a string that we're looking for. So we did see that the numbers, distinct where it was in here. So hopefully these numbers change a little bit. So let's give this a run and see if we match that okay. Hey, that's good to see. No errors, right? No typos. So now we have the lower count, and these, of course, are all customers that have this item, right? That ordered this item, road-250 red, 52. I believe that's a type of bike. All right. What about aggregates? So of course we can do those, right? Working with Spark here, lots of things we can do. Let's go steal some code again. So this next one, we're just simply going to group the data and then display it. So do the select, right? And then we're going to group by the items, and we're going to sum those items. It's a great way to, like I said, do aggregates. Pretty easy to do that. We can see the sum of the quantity. All right, what else to do? We can do the transformations. One of the things about doing transformations is we're often creating new data frames. So let's come over, steal a little more code again. Right, and this time I'll grab kind of a longer one, longer piece. Yeah, it's kind of good that I have those, that nobody's watching me type all this in. So in this case, what's happening is we're taking that original data frame and we're going to modify it, say, hey, with column. So we're going to add a new column called year. It's going to be based on the order date. We're going to extract the year from it. And we're going to add another column called month, extract that from the order date as well. and that's going to be our transformed data frame. And once we have that, we can play with it a little bit more. So using the transformed data frame, let's add, first name, and a little further over, we add the last name. So we're just splitting the customer name in two. So get the first item, get the last item. When we do the split, so now we have a first name, last name, and then we're going to reorder some of the columns to show it. So all of this is going from our original data frame that we're using previously, creating this new transform data frame, and then we're going to display it to see if we actually got these, 4 new columns: year, month, and then first name and last name, right? Based on the original columns. So when we do that, right, way over should be here. We see the year and the month, as well as the first name and the last name, added to the column. So we can manipulate this. We can manipulate any of the data frames, produce new ones, and of course we could write this out as well. So speaking about writing it out, how do we do that? So let's add another frame in here. And writing is actually pretty easy. So we're going to take that same transformed data, that data frame, right? So the data frame, we're going to write it out. And we can specify a lot of things. So in this case, we're going to overwrite any existing files. We're going to continue to use a Parquet format, right, for this. Originally, they're CSVs, so we're actually writing a different format. We're going to persist it in its own folder, transform data, and say, hey, it's all saved. Now, once we do that, right, it's going to write that out. We could look at the logs, make sure that it goes. That's the print. And what we'll need to do is come over and actually just refresh this, right? So now what we should see is a transform data. And if we open this up, it's a pane I collapsed earlier, we can see the transform data, and under orders, we see the Parquet format for this, right? So it worked pretty good. Next up, what about partitioning? So we can have a lot of data. What might that look like? So let's come over and add another cell. Let's go steal a little bit of code. We'll do this all together. So what we're going to do is read some data back in. So we can read that data in, and we don't need that. So we're going to read in the data that we just saved, we just persisted. We're going to read that into its new data frame. We're going to display it. But then we're going to write this back out. We're going to partition it by year and month, right? Overwriting it. And this one's going to go into its own folder, right, called partition data. And we're going to save it. So let's see what happens here. All right, so we see the display of orders DF, right? This is the new data frame that we just created. And if we come over to the files now and refresh this, hopefully we see partition data. Now, what should be different here is when you expand this, remember partitioning is going to create a folder structure. And sure enough, we see the year, and we expand any of the years, we see the different months, right? So we now have partition data, and we select any of these, of course. We can see the Parquet file that represents the data that's filtered, for 2019, in the 10th month in this case, which would be October. Excellent, excellent. All right, let's go back to our notebook. Let's come down to the bottom here. Likes to reset this currently, and let's do another code block so we can play a little bit more. With that partition data, one of the common things that we want to do is read perhaps just a part of this data. And so this next block is really to read everything in, but you'll notice something that's a little bit different on the load is that we can specify a wildcard, right? Or be specific for the folder structure. So year equals 2021. We're going to load, year 2021, but we're going to grab all of the months. And we can play with this however we like. So if you wanted, just January data, you could put a wildcard for the year and then specify the month number to be specific, right? So you can play with that structure a little bit. And when we do that and display that, you notice that we're only going to get the 2021 data, but notice we're also getting all of the months. I've got to go down quite a bit, I believe. See if we can get any of the other months. They are there. That's just, we have a lot of data in here, right? So we can play with that if you want to. There's just a lot of rows. It only grabs the first 1,000. So, but the data is in fact there because this worked okay. All right, let's do something a little different coming up. So the next part, we've been working with Spark so far, doing the filtering and using the methods and all that, very effective. But a lot of people still like to use SQL. So two ways that we mentioned in the presentation portion of this is that you can do SQL commands with the spark.sql command. So let's grab some code here. It's right here, spark.sql, and then we can give it a SQL command, right? And then, so it's just kind of part of the results, and then work with it. So that could actually be all kinds of things. It could be a select statement, it could be, that's doing filtering. And you notice that this actually does work. And one of the things right before this, we haven't really done too much with this yet, but we'll talk more about this in our next session. But this first part is to take that data frame that we used initially and write it out as a Delta format, but save it as what's called a managed table. And then we're using the SQL against it. So SQL really looks for tables that are defined. So that first line actually did it. The describe is work, so we can see the description of the table. But if we come up to the tables here, we actually just need to do a little refresh. We should see the sales order table that we just created, right? It might take a tiny bit to create that. There we go. Sales order, just had to expand it. The sales order table that we created at the first part of that code frame. Now, it's not the only way to do SQL though. So we can also use the magic commands to do this if we want to. And so an example from this, so let's come down and do a magic command. As soon as we specify the %% SQL, this will change the cell to really behave as Spark SQL instead. And then we can just go right to a SQL statement to do everything. So let's see if this works okay, and it should. Sure enough, we get the table. Again, the sales orders table here is something that was created as a table initially. So, all right. So can we visualize this? So if I just take this data, this is a little complicated. Let's simplify this a bit. And let's do the percent SQL. And then we're just going to select, whoop, don't know what happened there. My touchpad went a little off. Select and just everything from sales orders. All right. Now, when we see this, that's just the whole table. You notice in the results at the bottom, right? So the results in the bottom has a table view, but then it also has a chart view. And if I click on chart, it's going to show me the data. But then way over on the right-hand side, we can look at the options for the chart and change what this chart looks like, right? So, well, the key and the values, I don't want that. I want the key to be on check the sales order number. So I just want it to be item, and the values for this, let's go with something like quantity. So pretty simple. And a little further down, the aggregation for this, let's change this to maybe sum, and apply. And you notice that the chart changes on it. And we can save this out as an image. So even doing any of the graphics, we don't necessarily have to go to Power BI to do it. We can do things right here. However, Power BI is still a great asset because it allows a lot of interactivity for the end users, people that aren't going to be as comfortable or knowledgeable with working with notebooks. All right. Now, that was still a little bit interactive, and a lot of people might go, I'd rather this be actually written out in code. So the answer is yes, you can. Of course, you can do this. I'm going to grab a little snippet here. And so we can use the matplotlib to create these visuals as well. Now, in order to use matplotlib, it requires a pandas-based data frame instead. So we're going to take that, the DF Spark, which just want to make sure we define somewhere. I'm not sure we define this. Let me get a sec. May need to define that. Yeah, okay. So just forgot a little bit. Let's come back in here. DF Spark is right in here. Let's just pop that up above here. And there we go. So this is just another example that I have. We're going to take a SQL statement and we're going to run it as SQL. So similar to what we did before and do that, but we are defining this df spark data frame that we can use in this. So once we have that, this matplotlib, plot, right, PLT in here, we can define all kinds of those visuals. And if I come down a little bit, you can actually see the bar plot of revenue by year listed out. So the first one was a SQL, but this one is from the matplotlib. Now we can take that further if we want to, because this offers a lot of ability to manipulate the visual, and we can do it all in code. So if we want to, let's say, whoops, that's the same one. Let's come down, change the area that it's in, rotate it, anything like that. Let's grab a little more code. So, gross revenue color is orange instead of blue. We can add the titles to it, so we can do a lot of manipulations, and then show this one. You'll see that it's similar but different, right? The visuals are different, so we can absolutely customize a lot of what's going on in here. Now we could continue on and play with matplotlib and do a number of other things if we want to. So changing the line style, changing the size of the figure. That's all very possible to work with. There is a possibility to work with other libraries though. So let me go and add a little more code, and let's grab more demo code. So let's use a library called Seaborn, which is actually based on matplotlib, and from there we're going to do something similar, and so we're going to grab the df sales and do this one, and pretty sure everything's, we have df sales okay. We're going to see that it's going to create another visual, but the point of this is really that we can use visuals from other places, there we go, like Seaborn, and manipulate those. So if there's a really custom graphic and you have a library for it in like Python, you can absolutely do something like that. So all of this, coming back to what's going on here, we're doing this with Spark, right? We're doing this with Spark in a notebook. Up at the top, we have the default language. When we run it, it connects to the session. And when we're done, we can save this and say, hey, I want to keep this notebook, run it later on or something. So let's do that. We'll call it, exploring Spark, something like that, and create that. Right, that's a sensitivity label. That's something a little bit different. And so now we can keep this for later on. It's going to be within our Lakehouse to play with, and we're good. All right, so with that, let's get back to wrapping up our session. For more information on the topics we've discussed in this session, you can check out the online material of Microsoft Learn, which you can find with the URL https://aka.ms/fabric-spark. In this session, we examined how to use Spark within Fabric, including how to load and transform data, and how to partition an output file. We also covered how to work with Spark SQL, and then lastly, we discussed how you could visualize data by using Spark. This concludes part 1. Let's recap all the content that you've seen so far. In session 1, we introduced end-to-end analytics using Microsoft Fabric. In session 2, we covered how to get started with using lakehouses in Fabric. And in this session, we examined how to use Apache Spark in Microsoft Fabric. Thank you for your attendance so far, and we look forward to seeing you next time for part 2 of this Microsoft Azure Virtual Training Day, implementing a data lakehouse with Microsoft Fabric.